Welcome back. In our previous video, we have learned about introduction to knowledge, why there is need for knowledge representation. Okay. In this video, we are going to learn about what are different approaches in order to represent knowledge. Okay. So our aim is knowledge representation. We have four different ways: relational knowledge is one approach, inheritable knowledge, inferential knowledge, and procedural knowledge. So let us see them one by one. The first one is relational knowledge. You must have heard this word in DBMS. You have learned about relational database in DBMS. What do you mean by relation? It is the way how two objects are related to each other, right? So here, in order to store a relational knowledge, what we have is, it is the simplest way of storing facts. Okay, so whatever is the fact, we can store over here. Each fact about a set of the object is set out systematically in columns. So you can see tabular format representation is seen over here. Okay, here I have players, player 1, player 2, player 3. This is my heading row. Here I have weight. Okay, weight of each player, like player 1 is weighted 65, player 2 has weight 58, player 3 is 75. Similarly, I also have their age. Player 1's age is 23, second's age is 18, and third's is 24. So whatever is the data, we have represented it using a table. Okay, so we can say that the fact about the weight of the player is 65. It is nothing but it's a fact, right? So the fact about that particular object is what player 1, it is set out systematically in the columns. Okay, these are the facts about the objects which are there in the columns. So this is nothing but relational knowledge. Now what is its problem of it? It is the simplest form of representation of knowledge. Okay, it is this relational is the simplest I can say the way to represent the knowledge. But what is the problem with it? It is having weak inferential capability. Like I cannot like if I ask question to this, like who is the heaviest player? Okay, if I ask question to this database, who is the heaviest player, it cannot find it directly by this particular table. Like the word heavy, it cannot link with this table. Okay, we understand, human brain immediately understand the one which weight is maximum will be the heaviest player, but the table won't understand because the word heavy is not there over here. Fine. So it is not able to answer our simple questions like who is the heaviest player. But if I write procedures for finding the heaviest player, okay, if you write certain procedure like heaviest player is nothing but go for max of weight. Okay, return max of weight. So then the fact will be fact will enable the procedure to compute the answer. So in that case, if I write a procedure along and this table I given as an input to that particular procedure, I'll surely get who is the heaviest player. Okay, so what is the drawback of this is it is having weak inferential capability. Inference is nothing but conclusion, right? Answering various questions, right? So when we are designing smart things, we want machine to answer it. Okay, so this way of representation of knowledge is not having very good inferential capability, like conclusions can be drawn little weakly. So we move on to second one, that is inheritable knowledge. What do you mean by inheritable knowledge? All the data must be stored into the hierarchy of the classes. We have studied classes in OOPS, right? So we have data which is stored in the form of classes. Okay, hierarchy of classes. All classes should be arranged in generalized form or hierarchical manner. Okay, I'll show you an example with respect to it. So elements inherit values from the other members of the class. Okay, so we'll come back to property inheritance. Just check out this particular example. So what you can see in this example, you have got adult male. Okay, player is one class. Okay, then player is a male. Okay, it is related with is a. So here I can say the boxes are the objects. These are nothing but the objects. Adult male is object, player is object, football is object, cricket is object. Like boxes represent different objects and values, and as well as values also. Okay, so the boxes represent objects as well as values. So player is an object. Okay, so value is adult male. Okay, and arrows represent the attributes. Okay, so this is nothing but an attribute. Either is famous attribute, instance is an attribute. Okay, so Peter. Okay, Peter is instance of this class. Cricket is one class, Peter is instance of that particular class. So they are related by which relation? Instance relation. Ankit is instance of football class, means he is a football player, and cricket player is Peter. Okay, in this fashion. So I repeat it in short, boxes are used to represent object as well as values. So I can say player is object, cricket is object, football is object. Adult male is value, Peter is value, Ankit is value. Okay. Then arrows are used to represent the attributes. Okay, this arrow line. So this is one attribute, this is the other attribute, is attribute. So there's one more example. Okay, so here I have cricketer, I have bowler, batsman. Okay, all these values are there. Okay, so here you can say Australia is one value, 708 is value, this is value, this is value, this is value. Okay, and all these we can say for example, these are all the objects. Cricketer is object, bowler is object, batsman is object. Okay, suppose shame one also you can take it as object, or you can consider as now these arrows are like they are joined with the help of arrows. Okay, these are nothing but attributes. So I can say the batsman's age limit is 50. I can say Tendulkar's team is India. I can say he made 15,500 runs and so on. Okay, so now here we can say that this is inheritable knowledge representation. So it contains inheritable knowledge representation which shows a relation between instance and class. Okay, so this is this is the relation between instance and class. Like Shane Warne is instance of bowler. Okay, it's instance of bowler. Tendulkar is instance of batsman. Okay, so this relation we call it as instance relation. Objects and values are represented with the help of boxes, as I have already said. Okay, so so here we come that it has got very important property, that is nothing but property inheritance. Okay, specific class inheritance attributes and values from more general class in which they are included. Okay, so specific class inherits attributes as well as values from general class. Okay, so that is called as property inheritance. Okay, so with respect to these examples, specific class can inherit their values, okay, from general class. Fine. So we go this structure what we've seen just is also called as slot filler structure. Okay, now let us see about the query. Does Sachin Tendulkar satisfies age limit? Can this particular query be solved by this example? Okay, so just let's see, can Sachin Tendulkar satisfy the age limit? So what you have to do is check directly whether Tendulkar is related to age limit. Okay, no. So what it will do further is it will check the for attribute instance, like Tendulkar, then it will go to instance of it is having batsman, because this values from batsman and are inherited over here. Okay, so this is I can say a general class and this is a specific class, so all values are inherited over here. So Tendulkar is instance of batsman and batsman's age limit is 50. So in this fashion, so 50 is followed by Tendulkar also. Okay, because everything is inherited over here. Okay, so answer is true. It will return true. Yes, he satisfies the age limit, like that. It is checked. Okay, so this representation is far more better than relational. Okay, third one is inferential. Inferential stands for what? It represents the knowledge in the form of formal logic or first order predicate logic. It is used to derive more facts. Okay, so now what happens, like it combines the knowledge to get outcomes. It guarantees correctness. Just see here for an example. Okay, inferential means what I have already said. It is nothing but you are trying to derive the conclusion. Let us see an example. Marcus is a man, all men are mortal. Okay, so this is one fact and this is the other fact. Now what I am going to do, I am going to conclude something out of these facts. So in order to do that, first of all we will represent this in logical format. So what is logical format? Man is a general class, and what is the specific example of it is nothing but Marcus. So Marcus is a man. So this is what we have written in this fashion. Okay, and what does it says? This is for all x such that man is such that x is a man. Okay, and all men are mortal. So this is written over here, all men. The x stands for all men, right? So all men are mortal. So in this format we can represent it. So here it is inferential knowledge. So we have to use first order logic or first order predicate logic or formal logic we call it as. Okay, so logic will be more cleared in our next video. Okay, because it is a part of our syllabus. So here I explain it again. Marcus is a man is one statement, all men are mortal is the other statement. So what you have to do is logical format we are representing that Marcus is a man. Now Marcus is a man, that's right. Now all men are mortal, I want to conclude from this. So I have taken for all x, man x means x is a man. Okay, x is a variable such that x is a man, such that all men are mortal. Okay, for all x this is true, that all men are mortal. So here one more example is there. First statement is John is a cricketer. So I can explain it with this example. Cricketer is general, John is its example. Okay, value, John is a cricketer. All cricketers are are athletes. Okay, so cricketer of x. So for all x, okay, cricketer of x, x is a cricketer such that x is athlete. Okay, so what is the conclusion? A cricketer is athlete. Conclusion is every cricketer is athlete. Okay. Fourth one is procedural knowledge. It uses small programs or codes which describe how to do the specific things. Like small procedures are there. Okay. So if then we remember if then, like if this is true, then do this. Okay. So it says how to proceed, right? Else go to else part, like that. So Lisp and Prolog are used for this purpose. It represents heuristic or domain specific knowledge, and production rules also can be used. We will see an example. So procedural knowledge as rules, like you can see over here, if ninth inning and score is close and less than 2 outs and first base is vacant and batter is better hitter than the next batter, then walk the batter. Okay, so anyways, whatever is written, if which is joined with different ands and then. Okay, so this is type of procedural language. So here again Lisp code is written to define a value. So this I've taken because Lisp language uses procedural. Okay, so it is used to define a value. So we have next we will see, I guess we'll see in next video. Thank you.